Okay, this is quiz 5 for 21C. The first question reads, find the center and radius of the sphere x squared plus y squared plus z squared, minus 6y plus 8z equals 0. Okay, notice we like the form of the sphere where we have x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is equal to r squared, because that tells us that our center is A, B, C, and our radius is R. Okay, so notice this is all of the points that are R distance from the point A, B, C. Okay, so that's our sphere. Radius R, center A, B, C. Okay, so in order to figure out what the radius and the center are of this sphere, we need to get it into a form that looks like this. And the way that we're going to do that is completing the squares. So if we break things up, what we've got here is x squared. Now x squared is fine because there's no other x values over here. So what this really is, let's not write x squared. Let's write this as x minus 0 squared. So we're good on that one. But now we've got y squared minus 6y. Now what we'd really like is a quantity y minus or plus some value b quantity squared. So what we can do is add in positive 9, because we notice that this is y minus 3 squared. So what I do here is I find the coefficient on my y, I divide by 2 and I square it and add that. Okay, so here when I divide by 2 I get negative 3. And then I square it and I add in and I get 9. Okay, so this is going to be the quantity y minus 3 squared. Okay, and then we're going to do the same thing with the z's. So plus z squared plus 8z. So again, we find the coefficient on our z term. That's 8. We divide by 2, which is 4, and we square it and add that on, and that's 16. But now we've added 9 and 16, both of them, to this side. And we haven't added them over here. So we need to add them on both sides, or else we've changed our equation. Okay, so if we add 9 and 16, we add 25 to the other side. So notice I can undo everything I've just done. If I subtract 25 from both sides, I end up with this is equal to 0. So these are equivalent. Okay, so if I rewrite this one more time, I get x minus 0 squared. Now y squared minus 6y plus 9 is y minus 3 squared. And z squared plus 8z plus 16 is z plus 4 squared, and that's all equal to 25. So that tells us that our center is the point 0, 3, negative 4. Now notice it's negative 4 because I have minus negative 4 in this plus 4. Okay, so I always want to have it minus some value. So if I have a positive, then I'm going to have minus the negative value. Okay, so my center is 0, 3, negative 4, and my radius is the square root of 25, which is 5. Okay. Now, problem 2 says, find the component form of the unit vector that makes an angle theta equals negative 3 pi over 4 with the positive x-axis in r squared. So if we draw a picture, this actually becomes very easy. Okay. So our positive x-axis, that's this axis, r in r squared. Okay. Now notice we want an angle of negative 3 pi over 4. Okay. So remember this whole thing is 2 pi, so this is pi over 2. So negative 3 pi over 4 is negative pi over 2 plus negative pi over 4. So we're going to be looking at this angle. Okay. So this theta equals negative 3 pi over 4. Okay. Now the unit vector, so we want this length to be 1. Well, something that's really nice about unit vectors is that if we remember our unit circle, we know that any point 1 unit out from the origin is described by cosine theta sine theta. And when I say points, vectors, right, we're talking about the same thing. We're just looking at the line directed towards this point. Okay, so what this vector is going to be is actually just going to be cosine of negative 3 pi over 4 sine of negative 3 pi over 4. Okay, so that's unit 1 because we know that cosine and sine, when we square them and add them together, we're going to get 1, and then when we take the square root of that, it's going to be 1. So that distance is going to be 1 for sure. Now I can simplify this a little bit. So cosine of negative 3 pi over 4 is negative root 2 over 2, and the sine of negative 3 pi over 4 is also negative root 2 over 2. Okay. Now the third problem says, find the angle between the vectors u and v, where u equals 2i minus 2j plus k, and v equals 3i plus 4k. Okay, now I'm going to rewrite these into the form of the vector form that I like. So I have u is equal to 2, negative 2, 1, and v is equal to 3, 0, 4. Okay, now one thing we know is that u dot v is u1 v1 plus u2 v2 plus u3 v3, where u1 is this value, u2 is this value, u3 is this value, v1 this value, v2 this value, and v3 is this value. Okay, we know that, and we also know that the value u dot v is the magnitude of u times the magnitude of v times cosine of theta, where theta is the angle between them. So notice this is what we're looking for. Theta is what we want to find, and we're able to actually calculate this, the dot product, and we can calculate the magnitudes. So we're able to find this value. This is completely determined. So if we first do u dot v as the dot product, u dot v, using this formula for the dot product, we're going to get 6 plus 0 plus 4. So what I did is I multiplied the first components, added in the multiplication of the second components, and added in the product of the third component. So this is 10. Okay. Now the magnitude of u is going to be just the length, right, of this vector. So the square root of 2 squared, which is 4, plus negative 2 squared, which is also 4, and plus 1 squared, which is 1. So the magnitude of that vector is the square root of 5. Now the magnitude of v is going to be, again, the distance, the length. So the square root of, now 3 squared is 9, plus 16 squared, 4 squared, which is 16. So this is the square root of 25, which is 5. Okay? So now what we've got is that u dot v is equal to u v cosine theta. We know what u dot v is, that's 10, so let's plug it in. We also know what the magnitude of u is, that's the square root of 5. We know what the magnitude of v is, that's 5. And then finally, we're looking for theta, and so we know that we're going to multiply by cosine of theta. Okay, so now if we want to solve for theta, so if we divide 10 by 5 root 5, so let's first divide it by 5. So this is going to end up being 2, and then we're going to divide by square root of 5. So 10 divided by 5 is 2, and then we divide by the square root of 5, like this. This is cosine of theta. So now we know that cosine is an invertible function, so theta is arc cosine or cosine inverse of 2 over root 5.